Hi guys, I'm Randy with BRStv, and today we're setting up a calcium reactor from a manufacturer synonymous with high quality in engineering, the RX-C 60 calcium reactor from Vertex. In today's Spotlight, we'll discuss some well thought out features for the Vertex reactor, go over what it comes with and how to set it up, then give some recommendations on tuning the reactor to your tank and some overall maintenance. There are several ways to supplement your tank's needs for calcium and alkalinity, and using the calcium reactor like the RX-C 60 from Vertex allows for more long-term supplementing of major foundation elements in a balanced approach, which can require less maintenance overall than other supplementing solutions, and if done right, is as simple as dialing it in and forgetting it. The Vertex Calcium Reactor helps to achieve this with unique features like an integrated flow meter that can give you a quick glance view of your effluent flow rate through the reactor, which allows for quick troubleshooting, such as when your effluent becomes clogged or needs adjusting. Along with that, there is an additional media chamber included, which you can fill with more reactor media for even longer CO2 contact time that helps to gas off excess CO2 and minimize the effluent's impact on tank pH, or even dissolve additional media specifically targeted at adding magnesium back into the tank. These reactors not only include a ventable lid to remove air inside the chamber, but also incorporate quick release push connect fittings, a built-in bubble counter chamber, effluent control with a needle valve, a probe port for pH control, and finally a quality recirculation pump from Seche with the Synchra Silent 1.5. When you open the box of the Vertex Calcium Reactor, you'll see it comes with the main reactor body that stands about 22 inches tall without the probes or lines attached, and can hold a little over 2 8-pound bags of media like this from Two Little Fishies. Next is the secondary media chamber for gassing off excess CO2, and a CO2 reaction chamber with media that's designed to increase surface area and CO2 contact time with the water inside the reactor. You'll also see the Seche 1.5 recirc pump, a bubble counter with a bracket for mounting the acrylic flow meter, and a needle valve for precise effluent drip adjustments. There's also 3 sections of 1/4-inch tubing for CO2, effluent output, and internal plumbing, and finally a base plate that provides an easy layout of all the reactor components that also allows them to be easily removed for individual maintenance or separated all together for those with tighter space requirements. Assembling the Vertex Calcium Reactor is pretty easy, especially if we use the colored tubing to our advantage, with white for the final product effluent, black for the CO2 coming in, and red for all other connections. For assembling the major components, we really just need to add on the CO2 reaction chamber and media, add on the recirc pump with the threaded union and intake connection, which you can see only fits one way when using the base plate as a guide. Next, we'll add on the bubble counter after pre-filling it with some tank water, and screw on the flow meter, drop in the needle valve, and place on the secondary chamber on the plate, and we're done. Moving on to the tubing connections, we highly recommend picking up a low-cost tube cutter like this to make clean 90-degree cuts that will increase the ability to make leak-free seals. Starting with the internal connections in red tubing, I'll start by connecting the bubble counter output, which is the connection without the red bubble count tube inside, to the CO2 reaction chamber input. One note here, using the built-in tube guides will help to keep everything separated and nice and clean when done. The next connection is for recycling excess CO2 that can get stuck in the top of the reaction chamber lid, which will get tied together like this. For this connection, you'll want to tie into the lid that has the lowest profile and not the attachment for drawing water. With that done, you can connect the other port in the lid down to the push connect fitting in the bottom of the secondary media chamber. Add a short line from the top of the secondary chamber to the bottom of the needle valve, and out of the top of the needle valve, connect a short line down to the bottom side of the flow meter. That's it for all the internal connections. Now let's switch over to the water lines with the white tubing, with one connection for the output effluent drip that will come out of the top of the flow meter, and one length of white tubing for your feed pump that will bring fresh tank water into the calcium reactor. After that's done, there's only one more connection to make until you're ready to get this reactor up and running, and that will be the addition of the black section of tubing for the incoming CO2 from your desired regulator. This connection will get tied into the bubble counter with the red tube inside, and we're done. As you'll see in the rest of this video, there are several choices and approaches to gear and methods when setting up a calcium reactor, which may work best for a majority of reefers but can be tweaked or changed if needed. With that in mind, I'll mention that there are a vast amount of reactor medias, CO2 tanks, regulators, feed pumps, pH controllers, and more to choose from, and not one is the absolute right way, but let's briefly discuss some more popular options out there and ones that we've used ourselves here at BRS. Your choice of CO2 canister and canister size is really a personal choice, with most reefers picking up a 5 or 10 gallon tank, which is typically available from many welding or gas supply stores. These are also available brand new, however, a quick search for a welding or gas supply company in your area will likely save you some cash on a pre-used and certified one. One quick note here, be sure to follow all safety instructions when handling pressurized gas like this, and if you have any questions, your local gas supply company should be able to provide you with safety information. There are solid regulator options available like this one from Toonsy, coupled with the most recommended solenoid from Milwaukee. Becoming increasingly popular in the hobby are the carbon doser digital regulators from Aquarium Plant Life that allow you to dial in your bubble speed from 0 to 10, which will give you a consistent bubble rate from about 4.66 bubbles per second down to 1 bubble every 10 seconds. A regulator like this is very reliable when it comes to using a pH controller to turn on and off the regulator by being able to shut off the gas supply, then provide the exact same bubble count after powering back on. Outside of that, you will need to supply tank water to your reactor, which is typically done with a small feed pump like a CJ or MJ1200, or tying it into a manifold port on your tank's plumbing. Lately, it's becoming more popular to feed your calcium reactor with a continuous duty dosing pump. However, some options can get pretty expensive, as most peristaltic pumps made specifically for our hobby are not capable of 24-hour pumping. However, there is a continuous duty option currently available from Chemour that allows you to choose a set dosing rate from 0 to 120 mils per minute, as well as make quick and simple adjustments to your flow rate. We'll show you how this can be a key component to making the tuning process to your reactor a very easy process. Let's talk about tuning and dialing in your reactor to your specific tank demand. As I mentioned earlier, there's a variety of ways to do this, and most have been used successfully by reefers. However, this is what we've had the most success with, which may be slightly different than Vertex's recommendations. Keeping that in mind, and to make the setup as easy as possible, we're going to get this done by following 3 simple steps which should hit about 90% of reefers out there. We'll start by setting the amount of calcium reactor effluent dosed to the tank, setting the rate that the media dissolves, and tuning that effluent dosing rate until it meets our tank's needs. Starting first with the flow rate at 20 mils per minute, which might vary with your specific size of tank and how it's stocked, but it's best practice to start low and work up. For this, some reefers will have a feed pump like the small CJ or MJ pump and a valve on the effluent line to control the amount leaving the reactor. We highly recommend verifying the flow rate with a graduated cylinder and measuring the amount of fluid being dosed in a minute, and this is where the built-in flow meter comes in handy to help verify the rate, but be sure to tap it in case bubbles get trapped inside and throw off the reading. Again, the continuous duty dosing pump with adjustable flow rates is my first choice for this step because I can simply set the flow rate to 20 mils per minute after calibration and I'm done. The second step is to set the rate that the media dissolves inside the calcium reactor, which will come down to the pH inside the reactor chamber. The most common range for pH to aim for is typically anywhere from 6.3 to 7.2, but a solid starting point will likely be somewhere right in the middle at 6.7. To keep the pH at that set 6.7, we'll need some controller like this one from Milwaukee, or via a controllable outlet with those who have an aquarium controller like the Neptune Apex. Either way, you can set these controls to turn off the CO2 to the solenoid and regulator when the pH reaches 6.7 and back on when it rises above. The bubble rate comes into play here as well, since more CO2 in the reactor will lower the pH and less will let it rise. Again, typically a starting bubble count of 1 bubble every 3 seconds should be a good starting point for many reefers, and just keep in mind that the pH controller will tell the solenoid or regulator when to open and let those bubbles in. If you find that your pH doesn't get down to 6.7 with 1 every 3 seconds, you can slowly increase the bubbles like 1 every 2 or 1 every 1 second until it's able to hit that 6.7. Back to my recommendation for a regulator to get this job done. Although many reefers have been successful with standard regulators, it is nice to have an easy to adjust regulator with a small knob and set points that are accurate within 1/1000th of a second and will reliably restart at that same setting after continually being toggled on or off by the pH controller. Now that we have everything set and running, all we have to do is test our tank's alkalinity and make adjustments to the effluent flow rates from the reactor to the tank as needed. For example, if the 20 mils per minute is raising the alkalinity higher than our target, I can simply lower it to 15 or 10 or more until the alk stabilizes. The opposite can be done if my alk continues to fall and the reactor isn't keeping up. All I need to do is increase the effluent amount until my alk swings stabilize. This is where continuous dosing is particularly handy, as controlling the calcium and alkalinity dose to the tank can be as simple as turning a knob up and down to meet the demand, and in many cases may even be easier than two-part dosing. One quick note here, if you increase the flow rate significantly, you may also need to increase the bubble rate to keep the pH at 6.7. Here's some additional tips for what we already covered for the minority of reefers who this approach may need some tweaking. First is those with a very low demand system where 6.7 may still be too much no matter how low the dosing rate. For these tanks, you can simply change the target pH to something a little higher, like 6.9 or 7 or so on. Opposite of that, for reefers with very high demand tanks like those jam-packed with SPS, you can lower your reactor pH to dissolve more media faster, say around 6.3 or 6.4, and making flow rates adjustments from there. Finally, your choice of media can be a factor for those who fall outside of the original three-step process, in which case we always recommend starting with a medium coarse media for a good balance between surface area and to avoid clogging the reactor. This is something you can play around with if needed, where larger particle media may dissolve slower and be less potent, while the smaller granular media may dissolve faster due to more surface area and can result in a stronger effluent. Let's talk about maintaining the Vertex Calcium Reactor, which will mostly come down to adding media as needed, with some deeper cleaning maybe once or twice per year. Some reefers opt to simply add more media when the reactor becomes nearly depleted, but over time there's a little leftover medium that may start to clog the reactor as it becomes smaller in particle size. With that in mind, it's a good idea to pull the reactor offline a couple of times a year and give it a more thorough cleaning. That said, for tanks with fairly low demand on alkalinity and calcium or smaller tank volumes, a full reactor may last quite some time with one or less changes in a year, while those with much higher demands and larger tanks will likely change their media more frequently, several times a year. If you're looking to accessorize your Vertex Calcium Reactor, as we've already discussed, there are solid options for a regulator, like the carbon doser digital regulator, or even for a continuous duty pump like the one we demonstrated from Chemours. There are also a couple of options we'd recommend for a pH controller with a reliable and more cost-effective option with the Milwaukee 122 pH controller that provides a nice standalone option where you just turn the knob to your desired setting and let it control your CO2 input. Outside of that, for those who may have been looking for an excuse for a full aquarium controller, this may be your opportunity to pick up something like the Neptune Apex EL, which comes with a pH probe and 8 controllable outlets to run your reactor, along with a ton of other helpful control features. Thanks for watching, and if you have any more questions that we didn't answer here, feel free to give us a call, send us an email, or hop on a chat. See you next time on BRS TV.